Guys, I'm Brian Scott Shirley. I work for Pitt Community College. I am in the process of getting my FANIC certification. This class will be from Module 2. Okay, we'll go ahead and start, guys. What about safety? The safety of people is always the most important. Okay, so no matter what situation you guys are in, make sure that you're safe. Okay. The next step in safety, guys, is external devices. This could be PLCs, this could be I/O devices, things of that nature inside the robot cell. Robots is third on the list on safety. Okay, so like I say, make sure that you're safe, keep your external devices safe, and then your robots. The fourth safety rule in here, guys, is called tooling. Okay, the tooling is where the robot is actually working from. The tool inside the work cell, and also the workpiece. Okay. Right. Staying safe while teaching or operating a robot. Before teaching, visually inspect the robot, work envelope, and tooling. What we're saying by that, guys, is before you get in there with your teach pendant and start writing your program for a robot, you always want to inspect the robot. You're looking for damage. You're looking for leaks. Okay, oil leaks of any kind. Any damage that you see with a robot needs to be documented. Okay? Do not enter a robot that is on unless you have a teach pendant in hand. Okay? We showed you guys a few minutes ago what the teach pendant looks like, and we're going to go over that a little bit more in a minute. But what they're saying is, guys, when you have a work cell, like the Versa 2 system that we got out here, that's much larger, when you're walking in their work cell, you should be the only one to walk in that work cell with a teach pendant. Okay? You shouldn't have other students in the work cell along with you unless they have a teach pendant with them. Okay? The teach pendant is what they call the enabling device. Okay? That is what we use to operate the robot. Okay? Know the path that can be used to escape. What they're saying here, guys, is that when you're inside that robot cell writing a program with your teach pendant, you're going to be in awkward positions trying to write your program. You're around obstacles. You need to always have an escape route. Okay? If something would happen while you were in there writing the program, you need to know where to go to get out of that work cell, to get away from that robot. Okay? Robots are extremely fast, guys, especially in a production atmosphere. Okay? Use low motion speed and single step tests. Okay? What we're seeing there, guys, is that we can adjust the speed of how fast the robot's moving when we're writing programs. And we can also, when we're testing programs, we want to single step the programs. Okay? What we're saying there, guys, is we're going to go one line at a time. And we're going to look at where the robot's going, where the tool's going to be located, and things of that nature. Okay? So that's one of the cardinal rules, guys, is use a low motion speed and single step your test. Okay? After you single step it, then you can take single step off and run the entire program one line at a time, or all the lines at a time. Okay? Right. All right. Parts of the FANIC educational training card. What this is, guys, it's a card built specifically for education. Okay? The mechanical vise, we have an LR-made 200 IC robot arm. Okay, this is a 6-axis robot. The pneumatic end of arm tooling, we call it E-yoke. The end of arm tooling is the gripper. Okay, there is a lot of end of arm toolings that FANIC can be used on FANIC robots, guys. This is a gripper. Okay, we're using the R30i8 make controller. The controller is where the software is housed, and it's like the computer or the brains of the robot. Okay. We have a 110 volt air compressor for the gripper. Okay, the gripper's pneumatic control. I have to have air compressor for that. We have a 110 volt transformer, and we have a camera for FANIC IR vision. Okay, that camera is used, guys, for if you were writing a program for specific colors. That IR vision, infrared vision, would distinguish the colors of what you're picking up as far as material concerns. Okay, and then we have the teach pendant. Okay. All right. Describe the teach pendant device and how it's used. This is what the teach pendant is going to look like, guys. All right. What is it used for? It's used to move the robot. Okay. What we're saying about moving the robot, guys, we're going to jog the robot axes. Okay, one at a time in just a few minutes. Okay. We can create teach pendant programs. We can test programs. We can run programs in production, and we can check robot status. What we're saying about robot status, guys, we can look at the input outputs and see what's on and see what's off, okay, while we're working. Parts of the teach pendant. We have an LCD screen. We have status indicators. We have an on-off switch, which enables the teach pendant. We have an emergency stop for emergency situations. Okay. And we have a dead man switch, and we'll talk about that in just a few minutes along with the numeric keypad. But these are the topics of discussion concerning the teach pendant. Okay. All right. We're going to get into the eye pendant right quick. Okay, this is the RJ3IB teach pendant. You notice it's got a hanger up here, guys. This hanger allows you to hang your teach pendant on your robot suit. Okay? Lightweight, ergonomically comfortable body. Very ergonomic, guys. When you wrap your hands around this teach pendant, it feels good. It feels like it's made for your hand. Okay? Now, the next part. 3-position live man switch. Okay? What we're seeing, guys, on this teach pendant back here, this teach pendant device has got a safety feature on it. It's got paddle switches back here, okay? These paddle switches are 3-switch controlled, meaning that when you squeeze the teach pendant a little bit, it falls in the center position and allows you to move the robot when you hold shift and you're jogging. If you squeeze that teach pendant too hard, it's going to cut that robot off or stop that robot's motion, okay? So if you don't squeeze it enough, the robot's not going to move. If you squeeze it too hard, the robot's not going to move. Okay, so you have to hold that paddle right in the center of the switch. Okay.
Do you have to hold both of them?
No, just one. Just one. And what you're going to do, Craig, is you're going to have your finger on the shift button when you're actually moving the robot.
Does it matter which one you hold?
No, sir. It does not matter which one, whether you're left-handed or right-handed. Okay. So we'll let you guys move the robot a little later on and let you try that 3-position. They call it a dead man switch. I'm actually calling it a live man switch because we don't want anybody to die. Okay? So that's a lot more positive wording right there, okay? All right. Okay, the next part, teach pendant status indicators. Teach pendant has several indicators to assist you in determining control status. Table 5.9, teach pendant status indicators list and describe the teach pendant status. You have a fault light, okay? So when we power the robot up and the controller up, there will be a fault error pop up on the screen, okay? In order to clear that error, you have to hold that dead man in and you have to hit the reset button along with shift and it will clear that error, okay? So any problems that you got, you always want to look in this section right here and see what exactly is going on, okay? You have a hold button. The hold indicates that the robot is in a hold condition. Hold is not continuously during a hold condition. What they're saying, these guys, is that if I was going to stop that robot, there's a few ways that you can stop a robot. Sure, you can let go of the dead man switch and it will stop, but when it does that, it applies brakes and cuts the servo power off. It actually stops it hard. It's a very hard stop. So I prefer my students, when they're stopping the robot, they either push the hold button or let go of the shift button. It decelerates slowly. It's a lot better mechanically on the robot. Okay, when you hit the hold button instead of letting go of the dead man. Okay, you have a step indicator. Lets you know whether you're stepping through the program one at a time. If you have step off, it's going to go continuously through the program. Okay, you have a busy indicator. Indicates that a controller is processing information. You have a run. Indicates that a program is being executed. And you have IOs indicating that the input-output is enabled. You have a production light, indicates that the robot's in production mode, and a T cycle, which is a test cycle, which will allow you to test your programs in specific ways. Okay? Right. This is the on-off switch, guys. This enables the teach pendant and programming when turned on. Okay? I try to tell my students, guys, you really want to turn the switch on when you want to move the robot. There's a lot of things you can do in this teach pendant without having to turn that teach pendant on. Okay? So you can look at your programs. You can do a variety of things on the teach pendant, guys, without actually having to turn it on until you get ready to move the robot. Okay? When you turn that on, you're allowing you to get ready to move the robot. Okay? All right, the emergency stop button. Use this button to stop a running program. What it does, like I say, it turns off drive power to the servo system and applies robot brakes. Okay? Now guys, just like it says emergency, you want to use the emergency stop button in an emergency situation. And when we talk about the robot cell in a minute, guys, there's an e-stop on the controller. There's an e-stop on the teach pendant. So you've got two e-stops within a pretty good distance from, the operator of the robot. Okay. A lot of cells that they make, like the Versa2 robot cell, has got an e-stop on the front of the cell. So there'll be e-stops kind of wrapped around the robot cell most of the time. Okay. You only want to hit that e-stop in case of an emergency. Okay. It's kind of harsh on the mechanism and the robot. The screen. You have a nice colored display, visual display. It's kind of like what you would call Windows. Windows pop up. We'll show you what that looks like in just a few minutes, guys. Very easy teach pendant to use. Okay. Now we're going to look at some of the keys on the teach pendant, guys. The reset key. Use this key to clear alarms and faults. Okay. When we fire the robot up in a few minutes, guys, you're going to see me hold the dead man switch. I'm going to hold the shift button. My right hand's going to come over and hit the reset button, which is going to clear my faults to allow me to move the robot. Okay. You can hit reset to clear any alarms and faults. Okay. All right, shift keys. Okay. Now, depending on whether you're left-handed or right-handed, you can hit either shift key. Okay. But understand that when you're hitting the shift key, together with other keys, perform specific functions. Okay. Like for instance, if I was changing the group number, I would hold shift and I would hold chord, and it would change group 1, which is a robot, to group 2, which could be another device. It could be a position. It could be a conveyor. It could be things of that nature. Okay. Shift keys, along with speed, changes your speed a little different than just hitting the velocity button or the speed button itself. Okay. So you have to be careful. And you have to know when to hit your shift button and when not to when using a robot. Because like I said, they perform specific functions. Okay. Jog keys. Okay. One thing I want to tell you about the jog keys, guys, is that J1, J2, and J3 are what we consider major axes. Okay. The J4, 5, and 6 are minor axes. Okay. So, in a little bit, guys, we're going to talk about the world frame and how you jog the robot in the world frame. And we're going to talk about how you're going to know which way is X plus, which way is X negative, along with Y and Z. Okay? So these are the keys, guys, that you're going to jog the robot with. Okay? We're also going to show you in a few minutes jogging in joint, where you can jog each axis one at a time. The J1 axis, the J2, the J3, okay? And so on and so forth. Okay? So these are your jog keys, and this is what you're going to move your robot with. Okay. Jog speed keys. Use these keys to adjust the jog speed of the robot. Okay. The top right-hand part of the teach pendant, there's going to be a percentage sign. Okay. That'll go from 0 to 100%. These are your percent signs for your speed right here. Okay. Now, when you're just pushing the up button, if you're at a 0 and you're pushing the up button, it's going to go from very fine to fine to 1, 2, 3, 4, and 5. So we go to 10, 15, 20, all the way to 100. Okay. If I hold shift and hit the up button on speed, it goes from very fine to fine, 1, 2, 3, 4, and 5. It goes from 5, it jumps to 50, and from 50 to 100. So when you're writing a program and you want to quickly move your speed to 100%, I can hit it twice, and it goes right to it when I'm holding shift. Okay? So like I say, be careful, guys, when you're using a robot. Make sure that you know what those shift buttons do when you associate them with other keys. Okay? Alright, these are the program keys. These are some of the 3 keys that you're going to be using a lot in programming. Okay? These are the keys that allow you the select button. Start with that one. Displays a list of the programs. You can create programs from the select screen. You can look at programs. You can call programs up. You can do a variety of things. Okay? The edit button is what displays your current program you're in. Okay? So if you're writing a program and you need to go back to the select screen to look at a program that you need to call, then all you've got to do is hit the edit key back, and it'll take you right back in the program that you're working on. Okay? The data key displays the data screen. Okay? The data screen can list a number of parameters dealing with data that you're using in your program. Okay? So that's the program keys, guys. All right, the function keys. Function keys. Use these keys to take specific actions depending on the screen display. What they're saying is, guys, is that when you're using the material handling robot like we're using today, the F1 key is going to have point above it. It's going to be the word point above the F1 key. Okay? There's times, guys, when you're going to hit the next button right here, and when you hit the next button, other F number keys are going to pop up. Okay? So when you hit that next button, you can, if you don't find the F button that you're looking for, a lot of times you can hit the next button and you will find it up there on their screen. Okay? So F buttons are what we call function keys, and they take specific actions depending on what screen is displayed. Okay? Right. The next key, just kind of talked about that a few minutes ago. Use this key to display more information keys pertaining to the F1, F2, F3, F4, F5 keys when available. Okay? F1 in the beginning may say point, but when I hit the next button, that F1 button may change to something different. Okay? Like instructions. If I wanted to add instructions to the program, okay, and I couldn't find the instruction F button, I would normally hit my next button and it would pull it right up. Okay? Right. Cursor keys. Okay? Use these keys to move the cursor to enable navigation around the screen. Okay? So anytime, it's kind of like computer guys, you're going to see actually a little cursor up there on this teach pen. Okay? You can move that cursor around kind of anywhere you want to on the screen. Okay? You may have to go in and adjust a motion type. Okay? From a joint to another motion group. Okay? So you can navigate around with those arrow keys. Okay? Numeric keys. These keys are used to enter numeric values 0 through 9. You also have a minus sign and a comma and a decimal point. Okay? So just like a regular numeric keypad on the computer, you can go in and change the numeric value with just that numeric keypad right there. Okay? The enter key. Use this key to enter a numeric value or to select an item from the menu. So it's kind of like a computer, guys, when you're moving around with this teach pen, it's going to ask you, do you want to do a specific thing? You're going to hit the enter button just like you do on a computer, and it's going to hit set that, okay? So enter button is going to be used quite a bit on the teach pen. The step key. When in T1, T2 mode, use this key to switch between step, running one program at a time, and cycle running a program continuously, okay? So anytime, guys, we're writing a program, we're touching up a program, mainly writing a program, we're going to have that processor in T1. Okay? T1 is going to run that robot at 250 millimeters per second or less. Okay? Meaning that it's a lot more controllable, guys, if you're new at a robot, to put it in T1 than it is to put it on T2. You never want to put it in T2 in the beginning. Okay? So we'll keep the robot in T1, and we will step through our programs in the beginning. And once you're satisfied with your program, there's no dangers involved or anything, then we will actually take a step off and we'll do a program continuously. Okay? And we'll show you how that works in just a few minutes, guys. Forward key. Okay? The forward key is only used, guys, when you wrote a program. Okay? So if you wrote a program and it was 15 lines long and you want to forward in your program, you're going to basically hold a dead man, hit the shift button and hit the forward button, and it's going to go one line at a time. It's not going to stop. Okay? Unless you've got that step button on. Okay? Now, and that's, like I say, the forward and backwards button, guys, only work when you're trying to use this key to execute the program statements. Okay? So you're going through the program, you're just going to push the forward button and it's going to go one at a time. Okay? Backwards. Okay? Use this key to execute the previous program statement. Backwards key works the same way. You can go backwards in that program. If you need to back up a couple of steps, you can back up into the program where you need it to be. You can stop it right there. Okay? Now we're going to talk about the chord key, guys. The chord key is a pretty cool key. Use this key to select the jog mode. Okay? There are 5 jog modes with this teach pen, with this robot. Okay? We're going to concentrate on 2 jog modes. Okay? We're going to look at joint jogging and we're going to look at world jogging. Okay? We're going to explain this to you a little deeper in just a second. But in joint jogging, each axis moves individually. Okay? So if I want to move just axis 1, I'm going to hit the J1 button. If I just want to move axis 2, strictly axis 2, in joint, I can move axis 2, positive or negative. Okay? There are times when joint works really good, man, if you get into a problem, what's called singularity, where the arm actually stretches out, okay, and you can't move the arm, and it gets into an error code. We can use joint to get out of there, okay? We normally hit the J4 positive button a few times, and then it'll take us right out of that singularity move. So joints used to really get you out of problems, and it's the most efficient move with a robot, okay? I can quickly get to a position in joint a little faster than I can in whirl, okay? Because whirl, what does it do? It allows you to move to TCP, which is the tool center point, okay? The tool center point is where those grippers are, where it clamps down on a part. This would be your tool center point of that robot, okay? That tool center part changes when the end of our tooling changes, okay? So if you had something other than a gripper up there, the tool center point would be a little bit different than where it's located right here in this robot, okay? And there are times, guys, when you want to move that tool center point in a straight line, you want it to maintain a straight line, either straight up or straight down. Whirl's the frame to use on that, because all axes are moving at the same time, trying to keep that tool center point in line, okay? It's much harder, guys, for a robot to follow a straight line than it is for it to round the point off, okay? So just keep that in mind. And that's the coordinate kick. Now make sure, guys, while speaking of the shift button we talked about in the beginning, you know, when you're changing the frame, you're just going to hit the chord button by itself, okay? If you would hold shift in chord, you would be changing the group from group 1 to group 2 and group 3, okay? So be careful with that, and you don't need to hold the shift button when you're changing coordinates, okay? All right, jogging in joint, okay? Like we said, jogging in joint, guys, allows you to rotate each axis individually, okay? You notice on this robot, guys, you've got an axis 1 here, okay? You got an axis 2 located right here, okay? You got an axis 3 located in the back part, axis 4 right here, axis 5 is going to be right there, and axis 6 is going to move your tool center point, okay? Like we said before, your first 3 axes, axis 1, 2, and 3, are your major axes. Okay? 4, 5, and 6 rotate kind of the tool center point of the robot. That's your minor axis. Okay? All right. Whirl coordinate system. The whirl frame is predefined within the robot. So what we're saying is, guys, the default frame for a robot is called the whirl frame. Okay? The center of the J1 intersection. This is the J1 intersection right here. Of the J2. The points are measured from the origin of that point right there, okay? So the whirl frame origin is located here, and this is where your numbers are coming from. When you're storing your points, okay? You have an X, Y, Z, and a yaw, pitch, and roll configuration, okay? So it stores those points digitally, is pulling off of that whirl frame origin located right there in that robot. Alright, now guys, we're going to talk about the right hand rule. This works for robots, but you need to look and see where the power is being fed at. The power is being fed to the back of the robot. If you will stand behind the robot and hold your right hand just like this, it's X, Y, and Z. So you can use this right hand rule and tell when you pick that teach pennant up which direction this robot's going to go when you hit X plus. Okay? If I hit X plus, that robot's going to do what, Dustin? It's going to come towards me, right? Okay? And it's going to go away from me on X negative. Okay? And if I want to move the robot to my left, I'm going to hit the Y plus button. If I want to move it to my right, Y negative. Okay?
That's only when you're standing at the back of it.
Right.
If you're standing in the front of it looking at it, it'd be backwards.
It's going to be backwards. Exactly right, Craig. Exactly right. Okay? And that only works in whirl, guys. It doesn't work in joint. Okay? Remember, whirl is the default frame. Okay? And this is the right hand rule. And this works on a number of robots, guys, but it works on the robots. You have to know where the power is being fed into the robot. Okay? So that's a very good determination, guys, of whenever you grab a teach pennant, instead of hitting buttons, not really knowing, this will allow you to know where that robot's going when you move that robot. Okay? So the right hand rule is a very good thing. Okay? The item key. Use this key to select an item in a list. Okay? To select a line in a teach pennant program, press the item key, type the line number, and press enter. To select a line name list of system variables, press the item key, type the line number, and press enter. Okay? There's certain times, guys, I know when I worked in manufacturing, some of the programs I wrote were 300 to 500 steps. Okay? And if I needed to find a certain step in that program, which is very difficult, you have to scroll through that teach menu to find it. I could just hit the item number and go to line 265, and it would take me right there. Okay? So that item button is pretty cool, man. It allows you to get to where you need to get, okay, if you know. Okay? Right, the backspace key. Is use this key to delete any characters or number immediately before the cursor. Okay? So wherever your cursor is located, anything to the left of that, when you hit that backspace key, it's going to delete it. Okay? So if you're correcting a program, you made a mistake and you need to correct that, the backspace key works just like the computer does. Okay? It backs it up and allows you to make the adjustment on that. Right? The previous key. Use this key to display previous screens. Okay? You may have hit your next button to move to an instruction F button. Okay? And you need to back up so you can install this point. You would hit that previous key and it would take you one screen back, which will allow you to navigate that part of the screen. Okay? So what these buttons do, guys, up here, they help you navigate around this teach menu. Okay? So the previous button is used a lot, along with the next button. So keep that in mind. Menu keys. Okay? Menu keys allows you to get to a lot of areas on this menu. Utilities, test cycle, manual functions, alarms. If you need to look at the alarm history, okay, if you needed to see what time a crash occurred, you could do that in the alarm screen. Okay, the I/O screen allows you to look at what robot output controls the gripper. Okay, if I want to close the gripper, if I want to open the gripper, I'm going to go to the I/O screen, and that's going to tell me. Okay, it's going to tell me the digital outputs on the robot. Okay. There's a setup function, there's a file function for saving. There's a user function, select button, an edit button, a data button. Like I say, you remember, select, edit, and data is in the teach section, but it's also located in the menu section. So there's different ways you can navigate on this teach menu, man, without doing it. There's several ways you can do it anyway. Okay? There's a status indicator, position, system, and browser. Okay? So the menu button will get you into a lot of areas on the teach menu, guys. Function key. Use this key to display the supplemental menu. Typical functions available to press the function key or function abort. We're talking about function abort for a minute. Okay? If Dustin wrote a program, okay, you wrote a program and you're jogging a robot through your program, okay, you cut your enabling device off and you hand your teach pin to Craig. Craig wants to locate his program and run that. Craig's not going to be able to run his program until he function aborts yours. Okay, now it clears yours, not completely from the teach menu, but it clears it long enough to allow Craig to run these. Okay, it doesn't delete it, it just clears it. Okay, so that function abort key is used extensively. We'll tell you something else about a function abort key. If you've got 300 lines in your program and you're halfway through it, okay, and you're running production, and Dustin grabs the teach pin and he functions abort, you have to start that program over. You're not going to be able to start that program where you left off at because you just cleared it. Okay? So only hit function abort, guys, when you're changing from one program to another. Okay? So keep that in mind. Okay? It also comes with a disable forward backward button, change group. Okay? As far as changing group, guys, these robots could have multiple groups, especially those robots in production. Okay? This particular material handling robot that we've got in this educational cell has only got one group, and that's for the robot. If you had a conveyor hooked up to this robot, that you wanted to operate the conveyor, that would be group 2. So any other devices that you've got hooked up to your robot would be a different group number. Okay? Like on the Versa 2, we have a positioner that rotates 360 degrees. That is a group number. Okay? So we can quickly move the robot to our point. We can change that group number to group 2, and we can rotate the position if we had to. Okay? So that group button allows you to do that. Okay? You have quick and full menus, so you can change the way the menus appear. You can save, you can print screens, and etc. You can do a few other things with that. Okay? But the function key, being able to go and abort a program is where you're going to use that function key a great deal. Okay? The hold button. is one of my favorite buttons. Okay? Use this key to stop robot motion or to pause program execution. Okay? So what I want, what I tell my students, guys, in my robotics class is when you're getting ready to stop the robot, don't let go of the dead man and stop it so harsh. Okay? I want you to hit the hold button. When you hit the hold button, it gradually slows that robot down. Fast, but not quite as intense as that e-stop. Okay? Or let go of the dead man. Okay? It gradually slows that robot down. It doesn't apply brakes, but it slows it on down enough to stop the robot. Okay? And the hold is a good button to keep the robot in working condition. Diagnostic help key. Use the help key to get information about how to use the current screen. So if you're stuck on a screen, guys, that you can't figure out, then that diagnostic key or help key will help you kind of navigate through that current screen. Then you have a diagnostic key to display information, error messages, descriptions, cause, and remedy. So you notice that diagnostic key is blue right here, okay? So you would hold shift, diagnostic help, and it would go to a diagnostic screen. So if you had an error code, these error codes come in a numeric format, you can look at the diagnostic information that is displayed. You can find a cause and a remedy for the error code that you just popped up on the teach pendant, okay? Let's see here, guys. All right. Now it looks like my error is not really showing what I wanted to show right here, but we have a position key, okay? The position key, guys, is going to show you the X, Y, Z, yaw, pitch, and roll, which is the orientation and configuration of the robot at that point, okay? So anytime you're writing your programs and you want to hit a position screen, you're going to see that pop up there, okay? It may pop up there, a lot of different numbers. Some are in joint. You can change it to world or user. But like I say, it'll be the X, Y, Z coordinates and the yaw, pitch, and roll, which is the orientation of the robot arm. Okay? Display button. Use this key along with shift key to change the screen view from single frame, double frame, triple frame, or single frame with extended axis. So what they're saying is, guys, is that you can get this teach pendant screen split up. You can have your programs on one side, you can have a clock on the other side, and you can have a data screen showing you kind of what's going on in that program. So you can look at 3 different screens at one time if you wanted to, okay? Which is pretty cool, man. So the display key will allow you to change the screen view. I normally keep mine on single frame, but when I was working in production, I would always put it on double frame so I could see what time I need to go to break or what time I need to go to lunch. And it would have a clock, being displayed up there on the screen. Okay? So that display button's pretty cool. New Pendant eye pendant, same operation as the current eye pendant. Okay? We don't have the new eye pendant. Okay? We have what's called the current eye pendant, I think. Yes. The new eye pendant, improved performance, is interchangeable. It works with the R30IA and the RJ3IB, USB only.